So welcome to Chapter 11, Regular Expressions. Now at this point I really am assuming that you've mastered the material in the first 10 chapters of the book. You know what a loop is, you know what a dictionary is, you know what a list is. You don't have to write super complex programs, but I want to be able to use those in a sentence and not have you say like, well, could you define that? Well, if I start talking about things that are hard for you to understand, that's what those previous chapters and any previous courses are for. So regular expressions are they're a very interesting thing in programming. They are themselves a programming language. They're like this own little tiny mini programming language that actually you can use in many different programming languages. So you can use them in Python, you can use them in JavaScript, you can use them in Java, and pretty much any time you have some kind of a complex string matching or extraction, you will run across regular expressions. Now the other thing that's really important to point out is that you don't really need to know regular expressions. As what I'll be showing you throughout this lecture is two ways of doing things. One is kind of like the simple, using simpler capabilities that takes a little longer, and then using regular expressions, which tend to be more succinct ways, but then more complex. So a regular expression itself is a programming language that is specialized in string matching. It itself is a programming language. And the simple version of it is that it's just really clever wildcard expressions for matching, parsing, and extracting information from strings, which is a lot of what we've done so far in this class. And it's just a smart find or a search. Here's the Wikipedia definition of regular expression. And some of you are going to like regular expressions. As a matter of fact, some of you might say, why didn't we start doing regular expressions at the very beginning? It'll be very natural to you. Because some people want to think deeply about a problem and come up with this beautiful expression of the problem. Then they go like, here computer, this is my expression. Others like to use simpler multi-step. I find them fun, but they are their own language, and it's a language of characters rather than a language of tokens. So if you think of print and for and if, those are all tokens. They're word-like things, but in regular expressions, a single character. And it comes from a time in the 70s, and so it's a very compact little language. Regular expressions are a mark of coolness, for some value of cool. If you know regular expressions, people are like, oh, and they're not that hard to know, but they're so funky and weird that it's kind of special when you know it. So you should be proud once you understand regular expressions. It's sort of a mark of awesomeness, like a little regular expression tattoo, like my little tattoo that I have here. So regular expressions, when you learn it, it's like you've gotten yourself a really cool tattoo. So here's a quick guide. And I didn't write this quick guide because, I wrote this quick guide because I need it. As a matter of fact, I have it with me, have it printed out on a piece of paper. And some of the regular expression stuff I remember, and I can write simple regular expressions without looking at a guide, but other ones I need a little bit of help. So if we take a look at sort of this table, the way this table works is I told you that regular expressions is a language of characters. And so instead of if or a tab or something having meaning, what it is a character has meaning. So if you're in a regular expression, caret means the beginning of the line. Dollar means the end of the line. It doesn't mean caret or dollar. Caret and dollar are special characters. So it's like a programming language. Dot, asterisk, plus, brackets, and parentheses, among other characters, have meaning in this little programming languages. Little programming language. We make a little program that's really tiny and really short, which you'll see just in a moment. So if you're going to make use of the regular expressions, you have to import regular expressions. So you have to put that at the beginning of your application. You have to say import RE, so the RE library, and then you make use of these things with re.search. And so search is the name of a function that's part of the regular expression library. You pass in parameters, and it's kind of like using the find method on strings. And there's a couple of different ways that you can take things. You can either use it to search for things and tell you, did you find something that matched this regular expression in the string, or look through the string and pull out pieces that match the regular expression. Okay, so here's our first example, and this is an example that tells us, very much like some of our earlier examples, we're looking through like the needle in the haystack problem, where we're going to open a file, and we're going to loop through that file, and we're going to take away the suffix, the blanks at the end, and we're going to check to see if the line we're using the find to say, does this line have the string from : in it? And so we're saying what position is it, and the position is line.find, and if that position is greater than or equal to 0, away we go. And so then we print the line. So this is like what this code really does is it looks through a whole file and shows you the lines that start with from. That's what this problem is solving. Okay? By now that should be relatively simple. Well, if we do the exact same thing in regular expressions, first we have to import the regular expression library. Let me change my color here. Import the regular expression library. Some of this is the same. We open the file, we loop through the file, we strip the characters at the end. And so now we're going to use, instead of the find operation, we're going to use re.search. So re.search is going to return us a true or a false, and it has a regular expression. Now later we'll see that this can be very complex. None of those characters, from, are special regular expression characters, and this is the thing we're looking at. We're saying find, look through this line here and find that string from. If it's there, you get a true. If it's not, you get a false. So this also will loop through the file, printing out the lines that have the string from in them somewhere. So we can make a tiny difference if we want, and actually in this case we probably do want to look for lines that only start with from at the beginning. And so in Python, with just strings, what we would do is we'd say, oh no, we're not going to use the find, we're going to use the starts with method. So line is that string of characters that come in from the line. And if it starts with a from : that's the line we want to send, right? That's the line we want to print. Well, in regular expressions, we're still going to use search, but we're now going to use one of these special characters. The caret is that special character that matches the beginning of a line. So if you look at caret from, what we're really saying in this little programming language is not look for the string caret, but instead say look for from at the beginning of the line. So we're asking a question here, dear regular expression, look through this line and find out if you find the string from at the beginning, and then return us a true or a false, depending on whether that happens. And so we sort of see, we change things, and you'll see in a bit that we will slowly but surely add more and more functionality and intelligence to these little regular expressions, rather than extending and adding more and more lines of code to our Python code. So that's the caret as our first thing that we learn. The next thing that we're going to learn is the dot. The dot is the wildcard character. And that's a little different than some things like star.star or whatever. Usually the star is a wildcard, but star's not a wildcard. The wildcard is the dot character. Star means any number of times. Any number of times. Asterisk, any number of times. Okay, so star means any number of times. So if we carefully look at what this is saying, what this says is, I am interested in my little programming language, I'm interested in matching the start of the line, followed by the letter X. The letter X is just the letter X, it's not special. And then followed by any character, and then these two things go together. Star dot means any character as many times as you like, followed by another colon. So the X and the colon are not special, they're not code, they're not on my little sheet of things that have meaning, but the caret means beginning of line, dot means any character, and star means as needed. Now, that means that some lines number of these lines will match. This has an X, all these lines have X at the beginning, and then they have some number of wildcard characters, and then they have a colon. So that's all we're saying. Find a line with X at the beginning, some number of characters, and then a colon. It doesn't, this is okay. We're not, if we wanted to say that was the last character, I could put a $sign here, and then that would say the line would have to end there, but then none of those things would match. So X and colon are real characters, and caret, dot, and asterisk are like part of the little programming language that we've got going on here. Now, you might want to do things like not have extra spaces, right? And so if we look at this in this previous one, we look at this X plane is behind schedule. Well, it starts with an X and then has a colon and has all these things. And we didn't really want to match that, but it looked to the regular expression like a thing that had an X plus a bunch of characters and then a colon. And if we want to clean that up, we can clean that up by just tuning a regular expression a little bit. We can be a little more explicit. we can say, you know what? We don't just want an X at the beginning of the line. We want an X dash. So that says I'm going to match X dash. And then instead of any character, which a dot would be any character, but backslash S, backslash on the sheet, backslash S says a backslash capital S says non-blank character. Any non-blank character, non-white space. And then instead of star here, star is 0 or more times, and plus is 1 or more times, followed by a colon. So this little programming language says the line must start with X dash, at least one non-blank character, but they all have to be non-blank up to the colon. And so this starts with X dash, at least one non-blank character, and a colon. Starts with X dash, any number of non-blank characters, followed by a colon. This one starts with X dash, it's fine, but now it says, oops, I am only looking for things, I got to find the colon before I hit a blank before I found the colon, so this line doesn't match. So take a look at it. You see how we're just slowly but surely adding a single character or a couple of characters, and it turns into code, right? These are, we are communicating with this regular expression code and telling it what we want to do. Now, maybe we are not making any sense, and it's quite often when you're making a regular expression that you won't make any sense. So the search tells you the true or false, whether or not you're going to find what you're looking for or not find what you're looking for. And then the find all will go through a string and look for something to happen multiple times. And so this slide also introduces a new syntax, and that is the bracket syntax. And so the square brackets enclose a set. And so the square bracket is a single character. And what's in between the square brackets is the legal things that we're willing to take. So what I'm saying here is this is one digit. So bracket 0-9 close bracket, that says one digit. And then the plus as a suffix says one or more digits. If you had star, it would be 0 or more digits. But in this case, I'm saying at least one digit and then any number of digits. Okay? So that is a digit. Somewhere in the range 0 through 9, you can have things like A-Z in there. The sheet talks about this. So that's a expression. So at least one or more digits. And find all is another method within the regular expression library that says go through this string I'm looking at and find all the situations that all the substrings of that string that would match my regular expression. So just to express roughly what we're doing here, here's the string we're looking for, and we're saying, dear regular expression, find me any string that's one or more digits and give them back to me. That's one or more digits, that's one or more digits, and that's one or more digits. It's like give them back to me. And so it pulls those out and it puts them in a list. And so this is the list we get. And there's a lot of code in there, right? And this is a relatively simple regular expression. I'm looking for numbers. 1 digit, 2 digits, 5 digits, 100 digits, doesn't matter. Some numbers, pull them out, and then give me a Python list. So this is a Python list. So whenever you're extracting using find all, what you get back is a Python list. And in that Python list, we have 3 strings, 2, 19, and 42. And those are exactly those things. So that's a pretty powerful little bit of code to say, go through and find me all the numbers and give me the numbers. Don't just tell me that they exist, true or false, and I want the numbers to be pulled out. If you think about how you'd have to do that, I mean, you have to use split and you have to do some checking, check if they're integers. I mean, you could do the same thing with splits and a for loop and a couple of other things, but that's, 5, 6, 8 lines of code that regular expression does for you. Okay? So find all is our way of extracting data. Search is our way of asking whether there is a possible match. Find all both says, is there a match? How many matches are there? And what are the things that I extracted? And so if you look at this, the same string right here, the same string, and I used my one or more digits extraction, I get 3 things in a Python list. And if I say, I'm looking for any number of uppercase vowels, A, E, I, O, or U in a bracket, remember that's 1 character, and this is 1 or more. 1 or more uppercase vowels. So find me in this string right here, find me all of the sequences of 1 or more uppercase vowels and give them back to me. So it looks through, goes like, nope. So it gives us back an empty list. So the fact that it didn't find it at all is why we get back an empty list. We call find all, and you don't find anything. So it doesn't return false. It always returns a list, and if there was nothing found, it returns a list with nothing in it. Okay? Now, these matching operations are what are called greedy. And greedy means that as they're extracting, they're pushing outwards. And it wants to return in the return codes that you're getting. It wants to return the largest possible string. So let's just take a look at this. So here's a thing that says beginning of line, starting with an F, any character, 1 or more times, right? Actually, I already had those arrows right there. First character has got to be an F in the first character of the line, followed by any number of characters, blank, non-blank, because dot matches all characters, and then colon. So you think, oh, that's going to go from colon and give me that. But it doesn't, because it's greedy. And so it could either give you this matches and that matches. We could tell it, I'm not interested in a colon. You could say, start with an F, as many non-colon characters stopping with a colon. You could say that. So it could either legitimately say that is starting with F and ending in colon, or it legitimately could say starting with F and ending in colon. Greedy says prefer the larger. Right? So greedy says make the string as large as possible, and so that's why we get this string. Both strings legitimately match, but if you have a choice, take the largest of the 2 strings. So non-greedy matching. Sometimes if you really want to only stop at that first colon, then you add this little question mark. And the question mark says, don't do the greedy matching. Okay? And so that says, satisfy the regular expression with the shortest string rather than the longest string. And so other than this greedy matching, it starts with an F and ends in a colon, starts with an F, ends in a colon. Well, non-greedy matching says prefer this one. That's the one we want, because don't go as far as you can. And sometimes that's really important. And so in this one, we get from back. Okay? So that gives us kind of a start. We'll continue in a moment on regular expressions.